For example, suppose that F equals 5 and K equals 2. Now remember, F just represents the constant force that would be acting on an object. Think of a marble or a pool ball rolling down an incline underwater, and you have a force of 5. That could represent 5 newtons. Maybe it's a bowling ball. 5 newtons of force, and K equals 2. What is the meaning of K? Well, K is what you multiply by V, your velocity, in order to get your drag force. So that K would be in units of force divided by units of velocity, so that when multiplied by velocity you get units of force. And K might be, let's say, 2 newtons per meter per second, meaning if this thing's moving at a meter per second, it experiences a 2 Newton drag force. And that, of course, would be 2 Newton seconds per meter. Whether you understand the physics or not, the solution to the differential equation is fairly straightforward. Well, we've already solved the equation generally for arbitrary F and K, so that we can look at the solution for this specific instance. Now, we could always rewrite the equation and solve it using numbers instead of letters, but since we've already solved it symbolically, there's no reason to go back and do that, except maybe to further understand how these quantities relate to one another and relate to the solution. Okay, in any case, the solution then is, well, V of t. First of all, let's observe that V naught minus F over K is what? 0 minus 5 over 2, which is negative 5 halves. What's the meaning of that? Well, we could first perhaps have observed that F over K, which is the equilibrium velocity for this system, the equilibrium solution to this equation, is 5 halves. So that we expect from this case a solution where V approaches a terminal velocity of 5 halves. If the units are, as we say here, that would be 5 halves meter per second. We're starting from velocity 0, and we expect this thing to, in some fashion, approach this constant velocity as a limit. V naught minus F over K is negative 5 halves. What's this? Well, that's how far our initial velocity is from our terminal velocity, and it's negative because our initial velocity is below our terminal velocity. Our solution then becomes V of t equals F over K, which we've seen to be, well, here, let's say we've seen to be 5 halves, plus V naught minus F over K, well, that's negative 5 halves, and that's multiplied by e to the negative k over mt. So I'm just going to write that as minus 5 halves times e to the negative k over m multiplied by t. Now, if we had a value for m, we could put numbers in here, but the first thing I want to look at is the fact that our velocity function is 5 halves minus 5 halves times some exponential function, and that exponential function is approaching 0. Now, when t equals 0, this exponential function is 5 halves, and our velocity is 5 halves minus 5 halves, which is 0, in accordance with our original assumption that V naught equals 0. As t approaches infinity, e to the negative k over mt approaches 0, so that our negative 5 halves, e to the negative k over mt, approaches, did I say e to the negative k over mt approaches 0? As t approaches 0, negative k over mt approaches 0, so that e to the negative k over mt approaches 1, e to the 0 being 1, so that negative 5 halves times e to the negative k over mt is going to approach just plain old negative 5 halves times 1, negative 5 halves. and our v of t I said it wrong. Okay. Yeah, I'm going to leave this in here. Okay. I said it right the first time. I thought I'd made a mistake and hadn't. Again, as t approaches infinity, e to the negative k over mt approaches 0, so that 5/2 e to the negative k over mt is going to approach 0, and our velocity is going to approach 5/2. Once again, to clarify, hopefully, and eliminate any confusion. When t is 0, the exponential is 1. We get 5/2 minus 5/2 is 0, so our velocity t equals 0 is indeed 0. As t approaches infinity, e to the negative k over mt approaches 0, because this approaches e to a negative large power, so that this term goes away and our velocity approaches 5/2 exactly as we expect. Furthermore, if we were to invert this picture and make this line here our x-axis, we would have an exponential function that's decreasing toward 0. Okay, so that the difference between this function and 5/2 is an exponential. It's this exponential function, and that exponential function is subtracted from the v equals 5/2, giving us this graph shape.